So for this second portion of 1.6, looking at transformations of functions, a lot of this is going to be just taken from Desmos. Of course, we'll be graphing on hand and on paper and using our calculators, but I feel as if this is a really great way for us to look at all of these graphs, the parent functions, and also the modifications that can occur. So I'm going first to Desmos. If you've used this previously in Algebra 1 or Algebra 2, that's awesome. This is a free tool that you can use on your computer or even mobile, I'm pretty sure, if you need to graph out anything that you might need. We'll definitely be using this down the road. So with the first example, they have us checking f of x when this is equal to the square root. It's nice if you just type in sqrt, it'll throw that into the mix. So we have the parent function first, which, as we see here, let's throw in some notes. We know that the domain is going from, well, let's look closely. We know that the first x value that we could use is 0, and that's including 0. So let's say we have that. And we can assume that this continues in this pattern for quite some bit. No matter how large the numbers get, it's going to continue in this fashion. So we can assume that it's going to continue in that direction all the way to, so we're technical with it, positive infinity. And we'll use parentheses on that. If we're curious about the range is going to start at 0 and it keeps going up to there, infinity. So let's assume that this is going to be from bracket 0 to positive infinity. So the first example has us using transformations to graph this new function. We already used f of x, so let's use g of x. Let's call this g of x when this is equal to 1/2, taking the square root of x, and we're deducting 2. And we'll zoom in so we can see where the real important portions of this are at. So we see a slight modification from the original square root of 2. I'll give you a moment to think out what changed between these two graphs. Was there a vertical shift, horizontal shift? Did it scrunch up? Did it go away? Well, previously we were talking about the idea of high vo, which is saying that all the horizontal shifts are going to occur inside the parentheses or wherever x is. As we see, x isn't modified, so there's no horizontal change inside, at least. There is a vertical change, however, with this -2. So we can say that since v is representing vertical, as far as a vertical shift up or down, that occurs on the outside of wherever x is. So we see that this is modified down 2 units. So there was a vertical shift. Let's make this a note. Vertical shift of 2 units. We hopefully can see that there's a coefficient for the square root of x with that 1/2. This is correlating where it's in between 0 and 1. So we can say that this was compressed vertically by a factor of 1/1/2, which in this case we can say this was vertically compressed by a factor of 2. Because if we take 1 divided by that 1/2, that's implying that, or no, sorry, no, yeah, compressed vertically by a factor of 1/2. I was looking at the other horizontal stretch and shift, but that's fine. So we see that this is moving at a not as quick pace, but that's okay. But hopefully we can definitely see there's a vertical shift and it's not moving as quickly. This looks as if it's going pretty up and above, whereas this kind of does half as much work seen here.